A very warm good morning to all of you. This is Maria Pushpam. I hope you would have understood what I have taken in yesterday's class. Today we are going to see ultimate analysis of coal, then grading of coal, comparison of coal and coke. So first we can see what is said to be ultimate analysis. So coming to ultimate analysis, it involves determination of carbon, hydrogen, nitrogen, oxygen and sulfur present in coal. I'll repeat. So what I mean by ultimate analysis is it's an analysis which determines carbon, hydrogen, nitrogen, oxygen and sulfur present in coal. First we can start with measurement of carbon and hydrogen present in coal. So how to find the carbon and hydrogen present in coal is you take 2 gram of coal sample, weigh it accurately in a current of, you have to weigh it accurately, then you have to burn it in a current of air. As you burn the thing, what happens here is the carbon and hydrogen present in coal is oxidized to carbon dioxide and water. Now what you have to do is you take two tubes. One tube is packed with potassium hydroxide, another tube is packed with calcium chloride. And the purpose of taking potassium hydroxide and calcium chloride in the tube is potassium hydroxide has a capacity of absorbing carbon dioxide and calcium chloride has a capacity of absorbing water. So what happens here is both the things will be coming out of the container. Carbon dioxide will be coming and water will be coming. So what you have to do here is you have to absorb this carbon dioxide in the potassium hydroxide tube and water in the calcium chloride tube. So before absorption of carbon dioxide and water in these tubes, you have to weigh the tubes with potassium hydroxide as well as calcium chloride tube separately. So now if you weigh the thing again, what happens here is there will be an increase in weight of the absorption tube. So I'll repeat the point once again. So how you have to do this estimation or analysis is you take 2 gram of coal sample, burn it in a current of air you have to burn. As you burn the current of air, the carbon and hydrogen present in coal will be converted into carbon dioxide and water. So now what you have to do is you take two tubes. One is packed with potassium hydroxide, another one is packed with calcium chloride. As you absorb the thing, then you take the weight of the potassium hydroxide tube as well as the calcium chloride tube, and the increase in the weight of the tube is used for calculating the percentage of carbon and percentage of hydrogen present in coal. So how to calculate the thing is percentage of carbon is equal to increase in weight of potassium hydroxide tube divided by weight of coal sample taken into 12 divided by 44 into 100. I'll repeat, increase in weight of potassium hydroxide tube divided by weight of coal sample taken into 12 divided by 44 into 100. And how to calculate the percentage of hydrogen is increase in weight of calcium chloride tube divided by weight of coal sample taken into 2 divided by 18 into 100. And why we are using this 12 and 44 is 12 is the atomic weight of carbon, 44 is the atomic weight of carbon dioxide. And coming to hydrogen, we have 2 divided by 18. 2 is used for hydrogen and 18 is meant for atomic weight of water. So next we can see how to measure the nitrogen present in coal. So in previously we have seen how to find the content of carbon and hydrogen in coal. Now we are going to see what is the content of nitrogen in coal. So coming to nitrogen in coal, the method is called as Geldas method. So why we call it as Geldas method is it's a RB flask containing a long neck flask, and that flask we call it as Geldas flask. So the method is called as Geldas method. So coming to this method, what you have to do here is you take 1 gram of coal sample and you have to heat the sample with three ingredients. One is sulfuric acid, then potassium sulfate and mercurous sulfate, and this mercurous sulfate will act as a catalyst. So I'll repeat the point once again. So what you have to do here is you take 1 gram of coal sample, you have to heat it with sulfuric acid followed by potassium sulfate and mercurous sulfate. What happens here is the nitrogen present in coal is getting converted into ammonium sulfate. And to make this the clear solution is you'll get a clear solution, and to make the solution alkaline you have to add sodium hydroxide. As you add sodium hydroxide to the clear solution, you'll get ammonia will be liberated. Ammonia will be liberated, and this ammonia has to be titrated against N by 10 sulfuric acid. You take N by 10 sulfuric acid, titrate this solution. As you, after doing this absorption, you have to make the titration. After you make the thing for absorption of ammonia, after absorption of ammonia, you do a titration for what is the amount of acid unreacted. You have to titrate against sodium hydroxide. So from the amount of acid consumed, you can find what is the percentage of nitrogen in coal. So I'll repeat the whole process once again. So what you have to do here is you take 1 gram of coal sample, heat it with sulfuric acid, potassium sulfate and mercurous sulfate. As you heat the thing, nitrogen will be converted into ammonium sulfate, and this ammonium sulfate is said to be a clear solution. You have to make this as an alkaline one, so you add little amount of sodium hydroxide. As you add sodium hydroxide, ammonia will be liberating. So the liberated ammonia is being absorbed by sulfuric acid, and this sulfuric acid you have to titrate against sodium. The unreacted acid will react with sodium hydroxide. Is it okay? From that we can find what is the amount of acid consumed there by ammonia. So from this acid consumed you can find the percentage of nitrogen in coal. So percentage of nitrogen is equal to volume of acid consumed into normality into 1.4 the whole divided by weight of coal sample taken. I'll repeat the formula once again. Percentage of nitrogen is equal to volume of acid consumed into normality into 1.4 divided by weight of coal sample taken. It's clear with the method? I'll go with the next one. So next one is measurement of sulfur content. So coming to sulfur content, so previously what are things we have seen? We have seen how to find the content of carbon, then followed by hydrogen, then nitrogen. Is it okay? Three things we have found out. So remaining we have to find sulfur and oxygen. So sulfur, the method is called as Escas method. The method is called as Escas method. Why we call it as Escas method is a mixture is being used in this method with coal, and the thing is called as Esca. The chemical is called as Esca. I'll say what it is. So the method is called as Esca's method. So what you have to do here is you take 1 gram of coal sample. You take 1 gram of coal sample. You have to heat the sample in a platinum crucible with 5 gram of Esca mixture. I'll repeat. You take 1 gram of coal sample in a platinum crucible. It is heated with 5 gram of Esca mixture. So Esca mixture is nothing but magnesium oxide and sodium carbonate. In the ratio 2:1 we call it as Esca mixture. Magnesium oxide and sodium carbonate in the ratio 2:1 is called as Esca mixture. So what happens here is the sulfur present in coal is being converted into sulfur dioxide. Is it okay? So as you heat this Esca mixture with the coal, the sulfur present in coal is being converted into sulfur dioxide. Now what you have to do is, and it is absorbed, as sulfur is being converted to sulfur dioxide and is absorbed by the Esca mixture in the form of magnesium sulfate and sodium sulfite. What happens here is sulfur is being converted into sulfur dioxide. This reacts with the Esca mixture to give you magnesium sulfite and sodium sulfite. So these sulfites are extracted with water. As we make it to react with water, it gets oxidized to sulfates. So now what you have to do is you have to add 2 to 3 ml of bromine water, and you have to it is precipitated as barium sulfate by adding calcium, by adding barium chloride, by adding barium chloride. I have given as calcium chloride, but it is barium chloride. I'll repeat the process once again. And after that, the barium sulfate is being weighed. It is dried, and then it is you have to weigh the thing. You have to take the weight of the barium sulfate. From that weight of the barium sulfate, you can calculate what is the percentage of sulfur present in coal. I'll repeat the whole method once again, ma. So first what you have to do is you take 1 gram of powdered coal sample in a platinum crucible. You heat it with Esca mixture. As you heat with the Esca mixture, what happens there is sulfur is converted into sulfur dioxide, and this Esca mixture is now in the form of magnesium sulfite and sodium sulfite. This sulfite is treated with water, it gets oxidized to sulfate. Sulfite is being converted into sulfate. Then the sulfate is treated with bromine water and barium. I have given it as calcium chloride. It's not calcium chloride, it is barium chloride. So you treat with barium chloride. Then what happens there is this sulfate is being precipitated as barium sulfate. Now you dry the thing, dry the barium sulfate and take the weight of barium sulfate formed, and from the weight of barium sulfate formed you can find what is the weight of sulfur, what is the percentage of sulfur present in coal. So percentage of sulfur is equal to 32 divided by 233 into weight of barium sulfate divided by weight of coal sample taken into 100. I'll repeat, percentage of sulfur is equal to 32 divided by 233 into weight of barium sulfate divided by weight of coal sample taken into 100. It's clear? Okay, I'll go with the next method. So next is nothing but measurement of oxygen content. Measurement of oxygen content. So oxygen content is nothing but percentage of oxygen is equal to 100 minus percentage of carbon plus percentage of hydrogen plus percentage of nitrogen plus percentage of sulfur plus percentage of ash. So all the things has to be subtracted from 100. You get what is the percentage of oxygen present in coal. I'll repeat. So to find the percentage of oxygen in coal, what you have to do here is 100 minus all the things what we have calculated: carbon, hydrogen, nitrogen, sulfur, followed by ash. So all the things, if you subtract from 100, you get what is the percentage of oxygen present in coal. It's clear now. So Shija has asked a doubt how to calculate carbon, fixed carbon content. It's nothing but what you have to do here is, in proximate analysis, the 4 things we are finding. One is moisture content, volatile matter, ash content. Another one is fixed carbon. So we are estimating all the 3. இதெல்லாம் நம்ம வந்து moisture content கண்டுபிடிச்சிடுறோம், volatile matter கண்டுபிடிச்சிடுறோம், ஆஷ் கண்டனும் கண்டுபிடிச்சிடும். ஸோ இந்த 3ஐயும் கண்டுபிடிச்சிட்டிங்கன்னா 100லேருந்து அதை 3ஐயும் மைனஸ் பண்ணிட்டீங்கன்னா யூ கெட் வாட் இஸ் த அமௌண்ட் ஆஃப் ஃபிக்ஸ்டு கார்பன் ப்ரெசன்ட் இன் கோல். ஆஷ் கண்டுபிடிச்சதுக்கப்புறம் மீதியாக இருக்கக்கூடிய அந்த பார்ட்டிகிள்ஸ் இஸ் கால்ட் திஸ் ஃபிக்ஸ்டு கார்பன். துகள் சொல்லுவோம்ல, அதுதான் இஸ் செட் டு பி fixed carbon. Similarly, coming to oxygen content, in ultimate analysis what you have to do is you have to subtract all the other contents. It's nothing but hydrogen, carbon, nitrogen, sulfur plus ash. If you subtract all the things from 100, you get percentage of oxygen. Why we are subtracting? ஏன் எல்லாத்தையுமே நம்ம வந்து 100லேருந்து subtract பண்ணுறோன்னா, we are finding percentage. Percentageனால என்னது 100. So 100லேருந்து மீதி எல்லாத்தையும் கழிச்சிட்டோன்னா மீதி இருக்கதா என்னது percentage of oxygen. It's clear now? Okay, I'll go to the next one. Next is said to be grading of coal. So I have said you in the last class, we are doing 2 sort of analysis. One is said to be proximate analysis, another one is said to be ultimate analysis. The purpose of doing these 2 analysis is it's only to grade the coal. It's nothing but finding the quality of coal. நல்ல கோலா, இதை இங்கே யூஸ் பண்ண முடியுமா முடியாதா, Only for that purpose we are using this grading. So grading of coal. Coming to grading of coal or ranking of coal, three things are mainly used: proximate analysis, ultimate analysis, and the calorific value. Using these three things you can grade what sort of coal it is. So if you have a high calorific value, the coal is said to be a good quality coal. And the moisture content, volatile matter, hydrogen content, oxygen content, nitrogen content, sulfur, all this content should be lesser. If these things are found to be low, then we call the coal is said to be a good coal. And in the last class, we have seen a tabulation and have shown you initially wood will be there, then followed by peat. அடுத்த ஸ்டேஜில் வந்து லிக்னைட், அப்புறம் பிட்டமினஸ், அப்புறம் ஆந்த்ரசைட். அது உங்களுக்கு புரிஞ்சிருக்கும்னு நினைக்கிறேன். இட்ஸ் நத்திங் பட் முதல்ல அது என்னதான் இருக்கும்னா மண்ணோட மண்ணாக ஒரு பொருள் வந்து மக்கி போகும்போது இட் ஃபார்ம்ஸ் ஒன்லி வுட்டை தான் கீழே போய் ஸ்டாக்னண்டாக முதல்ல அது உருவாகக்கூடிய முதல் பொருள் என்னென்னா பீட்டு தான் கொஞ்சம் வருஷத்தில் உருவாகும். ஒரு 5 to 10 இயர்ஸ்க்குள்ளே பீட் ஃபார்ம் ஆகிடும். இஸ் இட் ஓகே? தென் ஒரு 50 to 60 இயர்ஸ் ஆகும்போது, 60 years 70 இயர்ஸ் ஆகும்போது இட் கெட்ஸ் கன்வெர்டட் இன்டு லிக்னைட். இன்னொரு 200 300 400 500 இந்த மாதிரி இயர்ஸ் போக போக இட் கெட்ஸ் கன்வெர்டட் இன்டு பிட்டமினஸ். ஓகே, தென் மில்லியன்ஸ் ஆஃப் இயர்ஸ் ஆகும்போது இட் கோஸ் கன்வெர்டட் இன்டு anthracite. Is it okay? ஸோ ஒவ்வொரு ஃபார்ம் ஆஃப் கோலும் வந்து இப்படி தான் ஃபார்ம் ஆகும். ஸோ இப்படி ஃபார்ம் ஆகிறதுனால we say anthracite is said to be a best quality coal. So same thing we are going to say here. If you take peat is found to be lower than bituminous. Peat is found to be lesser than lignite. Lignite is found to be a lower quality compared to bituminous. Bituminous is a lower quality compared to anthracite. Is it okay? It's clear? So this is said to be grading of coal, or we can call it as ranking of coal. Next one, we can see artificial fuels. There are two artificial solid fuels. One is said to be charcoal, another one is said to be coke. சார்கோல்னால் எல்லாருக்கும் என்னன்னு தெரியும், கறி கொட்டை சொல்கிறோம், தட் இஸ் செட் டு பி சார்கோல். அண்ட் கோக் இஸ் நத்திங் பட் இட்ஸ் யூஸ் ஃபார் த ப்ரொடக்ஷன் ஆஃப் ஸ்டீல். மெட்டலர்ஜிக்கல் கோக் அப்படி படிச்சிருப்பீங்க சின்ன கிளாஸஸில். மெட்டலர்ஜிக்கல் கோக் இஸ் நத்திங் பட் நம்ம பிரிட்ஜு கட்டுறதுக்கு, பெரிய பெரிய பிரிட்ஜஸ், ஹை ரொம்ப சீலிங்ஸ் உள்ள பில்டிங்ஸ், ஹை டாப் மோஸ்ட் பில்டிங்ஸ் எல்லாம் கன்ஸ்ட்ரக்ட் பண்ணுறதுக்கு தே யூஸ் ஒன்லி மெட்டலர்ஜிக்கல் coke, which is nothing but it's a form of steel. The main content of steel is nothing but carbon, and that carbon is said to be coke. Okay, so in the coke நமக்கு எங்கேருந்து தான் கிடைக்கும்னா we get only from coal. இந்த கிரேடிங் சொன்னோம்லமா, இந்த கிரேடிங்கை பொறுத்து தான் நமக்கு இது கிடைக்கும். Is it okay? So coming to this, we call it as coke. So there are two types of artificial solid fuels. One is said to be charcoal, another one is said to be coke. We can see what is charcoal, how it is being produced. Then we can see coke and how it is being produced and what is the use or difference, like that we can see. First we can see what is it to be charcoal, how it is being produced. Charcoal is produced by burning wood with limited supply of air. We have to take wood and you heat with a limited supply of air. It is said to be எப்படி இருக்கும், அது போரஸாக இருக்கும். போரஸ்னால் சின்ன சின்ன நுண் துவாரங்கள் இருக்கும். தட் வி கால் இட் இஸ் போரஸ். அண்ட் இட் பர்ன்ஸ், நிறைய புகை வந்து வராமல் அது எரியும் ஸ்மோக்லெஸ்லி. இட்ஸ் அ குட் ஃபியூல். அது எதுக்கு யூஸ் பண்ணுறோம்? இட்ஸ் யூஸ் ஃபார் த மேனுஃபேக்சர் ஆஃப் ப்ரொடியூசர் கேஸ். ப்ரொடியூசர் கேஸ்னால் எல்லாருக்குமே என்னன்னு தெரியும். இட்ஸ் நத்திங் பட் காம்பினேஷன் ஆஃப் கார்பன் மோனாக்சைடு அண்ட் ஹைட்ரஜன். வி கால் இட் இஸ் ப்ரொடியூசர் combination of carbon monoxide and nitrogen, we call it as producer gas. And water gas is carbon monoxide and hydrogen. So now this producer gas is produced by using charcoal. Other uses, it is used in metallurgy as a fuel. இது fuel கூட யூஸ் பண்ணிக்கலாம். Plus it is used for making carbon disulfide. So this is something about charcoal. Next one we can see what is said to be coke. So coming to coke, coke is produced by burning coal. Same coal you have to take, but you have to heat in absence of air. You have to how coke is being produced is you have to heat coal in absence of air, and it's coal is being converted into coke, and this process we call it as carbonization. I'll repeat the thing once again. So how this coke is being formed is you take coal, you heat it in absence of air. So as you heat in absence of air, this coal is being converted into coke, and this process we call it as carbonization. And now taking coke, all the coals cannot be converted into coke. Okay, all types of coal cannot be converted into coke. There are two things, one is coking coal, another one is caking coal. So we can see what it is. Coal which has a tendency to soften, swell, stick together during combustion is suitable for coke formation. எல்லா கோலையும் வந்து கோக் ஃபார்மேஷனுக்கு நம்ம யூஸ் பண்ண முடியாது. ஏன்னா நான் சொல்லிட்டேன், கோக் வந்து என்ன பர்பஸ்க்கு யூஸ் பண்ணுறாங்கன்னா பிரிட்ஜஸ் கட்டுறதுக்கு, அப்புறம் ரொம்ப சீலிங் உள்ள பில்டிங்ஸ், ரொம்ப ஸ்ட்ராங் ஹை டால் பில்டிங்ஸ் கட்டுறதுக்கும் தான் யாரை யூஸ் பண்ணுறாங்க, மெட்டலர்ஜிக்கல் கோக் வந்து யூஸ் பண்ணுவாங்க. ஓகேம்மா. ஸோ இந்த கோக்கை ப்ரொடியூஸ் பண்ணணுன்னா எல்லா கோல் வச்சு இதை வந்து பண்ண முடியாது. தெர் இஸ் அ கோல் கால்ட் அஸ் கோக்கிங் கோல். அந்த கோல் வச்சு மட்டும்தான் பண்ண முடியும். இஸ் இட் ஓகே? ஸோ இஃப் யூ டேக் கோல், ரெண்டு டைப் கோல்லையும் ரெண்டு டைப் இருக்குது. கோல் அதை எப்படி டிஃப்ரென்ஷியேட் பண்ணுவாங்கன்னா, இஃப் இட் இஸ் ஹேவிங் இட் நம்ம ஹீட் பண்ண உடனே சாஃப்ட் ஆகி ஸ்வெல் ஆகி ஸ்டிக் ஆகுதுன்னா தட் முதல்ல சாஃப்ட் ஆகணும், அப்புறம் ஸ்வெல் ஆகணும், அப்புறம் ஸ்டிக் ஆச்சுன்னா அதை எரிக்கும்போது அந்த ப்ராசஸ் எல்லாம் நடந்துச்சுன்னா இட் இஸ் யூஸ்ட் ஃபார் coke formation. This type of coal we call it as coking coal. மெயினாக இந்த பர்பஸ்க்கு யாரும் யூஸ் பண்ணுறாங்கன்னா bituminous coal வந்து யூஸ் பண்ணுறாங்க. ஓகே, நெக்ஸ்ட் ஒன் இஸ் நத்திங் பட் caking coal. Caking coal na enna, this becomes softened on heating, producing a plastic mass which is called as non-coking or caking coal. இதுக்கு யாரை யூஸ் பண்ணுறாங்கன்னா லிக்னைட்டையும் ஆந்த்ரசைட்டையும் யூஸ் பண்ணுறாங்க. ஓகே, ஸோ கோக் இஸ் அப்டைன்ட் பை ஹை டெம்பரேச்சர் கார்பனைசேஷன். எவ்வளவு டெம்பரேச்சர்னால் 900 to 1400 டிகிரி சென்டிகிரேட். இந்த டெம்பரேச்சரில் கோலை வந்து ஹீட் பண்ணாதான் நமக்கு என்ன கிடைக்கும், we get metallurgical coke. It's clear? So now we have seen two things. One is said to be charcoal, another one is said to be coke, and now we can see the difference between this coal and coke. If you take coal, coal is said to be a primary solid fuel. லாஸ்ட் கிளாஸில் உங்களுக்கு சொல்லி கொடுத்துட்டேன், ப்ரைமரி சாலிட் ஃபியூல்னால் என்னென்னா இயற்கையாக கிடைக்கிற ஃபியூல் தான் என்ன சொல்லுவோம், primary fuel. So coal எதுக்கு கீழே வரும்னா it is said to be a primary solid fuel. So coming to coke, coke எப்படிப்பட்ட fuelனா it's nothing but secondary solid fuel. Coke is said to be a secondary solid fuel. Okay, so second point, it's formed by decomposition of woody matter. If you come to coke, it is formed by destructive distillation of coal. Destructive distillation என்னன்னா, you have to heat coal in a closed chamber. ஒரு closed chamberல வச்சு, ஒரு closedஆன கண்டெய்னரில் வச்சு தான் அதை ஹீட் பண்ணுவாங்க. பண்ணிவிட்டு அதில் உள்ள அந்த வாலட்டைல் மேட்டர்லாம் மேலே போக விடாமல் அப்படியே அப்சர்வ் பண்ண வைப்பாங்க. ஸோ தட் ப்ராசஸ் வி கால் இட் அஸ் டிஸ்ட்ரக்டிவ் டிஸ்டிலேஷன். ஸோ அப்படி கிடைக்கிறதுனால அதில் நுண் துவாரங்கள் எதுவுமே இருக்காது. இட் வில் பி வெரி வெரி கம்பேக்ட். அதனால தான் தேர்ட் பாயிண்ட் என்ன கொடுத்துருக்கோன்னா, இட்ஸ் அ போரஸ் மாஸ். கோல் வந்து சின்ன நுண் துவாரங்கள் இருக்கும், கோக்கில் என்ன இருக்காதுன்னா no pores will be there, so it is said to be compact. And fourth one, it burns with long flame, and this burns with a short flame. And last one, it cannot be used for metallurgical process, and this can be used for metallurgical process. Is it okay? So this is something about coal and coke, and I'll summarize what we have learned today. You can understand. So what are things we have seen today is ultimate process. Then we have seen grading of coal, and last we have seen the two artificial solid fuels and the difference between coal and coke. And coming to ultimate process, I'll repeat what do you mean by ultimate processes. If you are estimating carbon, hydrogen, nitrogen, sulfur and oxygen, the process is called as ultimate process. And next thing what we have seen, it's nothing but grading of coal. Grading of coal is nothing but ranking of coal. And finally, we have seen the two types of artificial solid fuels. One is charcoal, another one is coke. And finally, I have said you something about the difference between coal and coke. Thank you for listening, ma. Keep on studying.